All right, here we have the targets 6 and 7 notes. We'll start with target 6. And target 6 says, I can solve an equation with rational exponents. Kind of similar to the lesson we did over solving equations with radicals, how we isolated the radical and then we took both sides to the power that would cancel out that radical. So it's going to be very similar to that. First, we're going to be isolating the term that has the rational exponent on it. So very, very important. Just like how important it was in the solving radicals lesson. So if we look at number 1, it says 4x to the power of 1/3 equals 12. Now if you notice, that 1/3 power really only applies to the x there. It's not applied to the 4 at all. So we have to get the x to the 1/3 power by itself. And to do that, we're going to divide both sides by 4. So then I get x to the power of 1/3 equals 3. Then what we're going to do is, and this is the same for every one of these problems, you're going to take the power that you have in front of you right now. So my exponent right now is 1/3. What I'm going to do is I'm going to flip it upside down and change it to 3/1. So that's the same thing as 3. And I'm going to take both sides of this equation to that new power of 3. And what that does is it actually cancels out completely that 1/3 power that we had before. So if we take 1/3 to the power of 3, or if we take x to the 1/3 to the power of 3, what we're doing is we're multiplying 1/3 times 3. That gives us 1, and it totally cancels out that rational exponent. So we're just left with x on the right side. I'm sorry, on the left side. On the right side, we have 3 cubed, and you can do that in your calculator, 3 caret 3, and we get 27. So x equals 27. All right, moving on. Let's look at B. We have 7x to the power of 1/2 minus 5 equals 16. I'm going to go ahead and add 5 first. You have to add 5 before you divide by 7 here. I get 7x to the power of 1/2 equals 21. And then my x to the 1/2 power is still not by itself. I have to divide by 7. That cancels. I get x to the 1/2 equals 3. And once again, I'm going to take the power that I have right now, which is 1/2, flip it upside down to make that 2/1, or 2. And I'm going to take both sides of my equation to that new power of 2. And that's going to cancel out that fractional exponent, or that rational exponent that I have right now. So my answer, on the left side, I just get x. On the right side, 3 squared is 9. So, same process for all of these. For C, I have 2x to the power of 2/3 plus 9 equals 17. Very similar to the one we just did. I'm first going to subtract 9. So don't divide by 2 first. You're first going to subtract 9. Then that leaves me with 2x to the power of 2/3 equals 17 minus 9, which is 8. All right, one more step to get x to the 2/3 power by itself. I divide by 2. So x to the 2/3 power equals 4. All right, same thing. I'm going to take the power that I have now, 2/3, and I'm going to flip it upside down to get 3/2. So I'm going to take both of these sides of the equation to the power of 3/2. Now on the left, you don't have to worry about that math. That just goes away. That's the reason we did it. On the left, I just get x. On the right, you're actually just going to plug this into your calculator. You're going to type in 4, and you're going to take this to the power of 3 divided by 2. So what you're going to do is you're going to type 4 into your calculator, then you're going to type the caret button, and it might look like this for you guys. Get different color. Type in 4, then you have a caret, and then you're going to type in 2/3. But what you have to do first is you have to put a parenthesis down and then do 2 divided by 3. Okay, or 2, it might look like this. 2 divided by 3. Okay, so if you're using the division symbol, 2 divided by 3. If you're using the caret and then you're using the fraction button, it'll just be, you'll type in 2/3. or 2/3. So what this does is it takes 4 to the power of 2/3 instead of taking 4 to the power of 2 and then dividing that number by 3. All right, so make sure you're doing that. So 4 to the power of 2/3, we'll type that into their calculator, and I get, oh, I'm sorry, not 2/3, 3 over 2, I can't believe I just did that. 3 over 2, my goodness. 3 divided by 2, which is what I had right here. I don't know why I said 2/3. I kept saying 2/3. 4 to the power of 3 divided by 2. There we go. And I get 8. You should get 8 in your calculator. Sorry. 3 over 2, not 2 over 3. All right. Let's do D. Make this smaller, kind of move it over. Okay. I have to get that x to the 2/3 power all by itself. So, first gonna subtract 5 from both sides. Not add 5. I don't know what's going on today. Alright, subtract 5 from both sides. So I still have x to the power of 2 over 3 over 4 equals 16. Alright, now to get rid of that x to the 2/3 over 4, that's a division problem on the left. And so to undo division, I'm going to multiply by 4 on both sides. So that will cancel. And I end up with just x to the power of 2/3 equals 16 times 4, which is 64. Okay, so now my rational exponent piece is totally isolated. I'm going to take the power that I have now, which is 2/3, flip it upside down to be 3 over 2, and take both sides of my equation to the power of 3 over 2, which is what I just created. That'll cancel with the 2/3. On the left side, I get x. On the right side, you're going to plug this into your calculator. 64 to the power of 3 over 2. And I get 512. So if you did not get 512, you're probably doing something wrong. Make sure you're typing in 64 with a caret, and then if you didn't put in 3 over 2 as in parentheses, you might want to do that. All right. E. I'm going to first add 2 to both sides. I get x to the power of 3 over 2 equals 27. And then I'm going to look at the power that I have right now, which is 3 over 2, flip it upside down to make 2/3, and take both sides of my equation to the power of 2 over 3. And I'm not using brackets for any specific reason. I just kind of like the way they look better than parentheses. You can use parentheses or brackets here. I just like being kind of fancy, so I like using brackets. Alright, those will cancel. On the left side, all I'm left with is x. That happens every time. That's why we're taking both sides to a new power. On the right side, you're going to type into your calculator 21 to the power of 2 divided by 3. And I got 9. So if you did not get 9, check your work in your calculator. Maybe you typed it in wrong. Maybe you didn't put the 2/3 in parentheses. Make sure you're doing that. Okay, F. Ooh, this is a big one. Alright, I'm gonna first add 2 to both sides. Now, if you notice here, I have it on the right side, I have -2 minus 4 times 2x plus 76 to the power of 3 over 2. So that 4 is actually being multiplied by that set of parentheses. So the only thing that's being added or subtracted here is the 2. So I'm going to undo that and add 2 to both sides. -866 plus 2 is -864. Let's check that. Yeah, -864 equals, and then I still have my -4 times, in parentheses, 2x plus 76 to the power of 3 over 2. Now I'll divide both sides by -4. That will cancel on the right. On the left side, I get 216. On the right side, I still just get my parentheses to the power of 3 over 2. Now, there's a lot going on in the parentheses on the right, but the rational exponent piece is completely isolated at this point. So what I'm going to do is I'm just going to take the power that I have now, which is 3 over 2, and flip it upside down, just like I've been doing, to make it 2/3. So then I'll take both sides to the power of 2/3. Alright, on the right side, it cancels. On the left side, I have to take 216 to the power of 2/3 in my calculator. And I got 36. So 36 is equal to 2x plus 76. So I didn't just get a number this time. I didn't stop there. I actually have to do a little bit more math now. That, when I took the right side to the power of 2/3, it undid the rational exponent piece, but I'm still left with everything in the parentheses, so I still have to do that math. So now I'll subtract 76. So 36 minus 76 gives me negative 40 equals 2x. Then I'll divide both sides by 2, and I get x equals negative 20. All right, and then g, let's see, if you notice that 3 is being multiplied by that 26 minus x, so I am just going to add 5 to both sides to start this problem. I have 3 times 26 minus x to the power of 5 over 3 equals 96. Then I divide both sides by 3. On the left side, I'm just left with, in parentheses, 26 minus x to the power of 5 over 3. On the right side, 96 divided by 3 is 32. Okay, and then I'm looking at the power that I have in front of me right now, which is 5 over 3. I flip it upside down to make 3 over 5, and I'm taking both sides to the power of 3 over 5. On the left, that totally cancels. On the right, I take 32 to the power of 3 divided by 5. So 26 minus x equals 8. I got 8 because I typed in 32 to the power of 3 divided by 5 in my calculator. Alright, to get x by itself, I'm first going to subtract 26. So 8 minus 26 gives me negative 18. So I have negative x equals negative 18. If I divide both those by a negative 1, I'll get x equals positive 18. Alright, and last one like this. The only thing I have to do here is divide both sides by 2 to start. Divided by 2 is 27. And now that my rational exponent piece is totally isolated, I'm going to take the fraction that I have, flip it upside down, and now I'll take both sides to the power of 4/3. On the left, they totally cancel. Oops, wrong color. So I'm left with 5x minus 19. On the right, I'll take 27 to the power of 4 divided by 3, and I got 81. Then, to solve for x, I'm going to add 19 to both sides. So I get 5x equals 100, and then I divide both sides by 5. X equals 20. Alright. Oops. So, to do these problems, all you're going to do is isolate the rational exponent term. So the term that has an exponent that's a fraction. And then you're going to take both sides to the power of that fraction flipped upside down. Then you'll solve for x if needed. Alright, let's do target 7 now. Target 7 is converting to and from radical and exponential form. So something kind of cool is that we can change from radical to exponential form and then back to radical form by just writing these a little bit different way. So something to note, and we've actually seen this before, is that the square root of x can be written as x to the 1/2 power. And we were actually seeing that when we were doing our graphing lesson. We were writing it either way. Square root of x, we were also writing x to the 1/2 power. And that was the same for when we were doing the cube root graphing. We saw the cube root of x, and we also saw x to the 1/3 power. Okay, so we can write these x terms back and forth between radical and exponential form by knowing just a couple things here. So what we're going to do is, if we're in radical form, we're going to take the root. So if we're doing the square root, that root is 2. If it's the cube root, we're going to take a 3, and that root goes in the denominator of our fraction in exponential form. You'll see what I mean in just a second. And then the exponent, so if you're looking at a right now, my root was 4, my exponent is 3, that goes in the numerator of my fraction in exponential form. Okay? So my root becomes my denominator, my exponent becomes my numerator. So let's look at a. I have the 4th root of x cubed. I'm going to start by just writing x. Now I'm taking x to the power of some fraction, so I'm going to create that fraction right here. My root, which is 4, becomes my denominator. So that 4 goes right there. My exponent, which is my 3, becomes my numerator, so that goes right here. So my final answer is x to the power of 3 over 4. That's the answer there. All right, let's look at b. I'm going to start by just writing my x and creating a fraction. My root is 5. That's going to go on the bottom. So I put my 5 there. And then my exponent, it doesn't matter if it's on the outside or the inside. I'm still going to put that on the top to look like that. So my final answer is x to the power of 2 over 5. And we'll do one more. So for c, I'm going to start by writing my x term, creating that fraction. My root, it's not shown, but it's an invisible 2. Whenever you don't have a root like that, it's always going to be 2. The square root. 2 goes in the denominator. And then my exponent, which is 5, it comes around and goes in my numerator. So my final answer for this one is x to the power of 5 over 2. You don't have to write them twice like I was doing. I was trying to color code them and then write the final answer again. But yeah. So that's how you do it. You take the root and it goes in the denominator of your fraction. And then you take the exponent and it goes in your numerator. So it says, what if the radical is in the denominator? Well, what we're going to do is we're just going to make the exponent negative. Okay, that's all we're going to do. Because we've seen before something like this. For example, x to the power of negative 2. Well, a negative exponent means we actually bring it to the bottom, and this becomes 1 over x to the positive 2. When I bring that x squared to the bottom, it becomes a positive 2. So same thing here. If it's in the bottom, I'm going to make sure that my exponent is negative, because then if I were to rewrite it the other way, I know that negative exponents means I bring things to the denominator. So I'm going to do this the exact same way I was doing it. I'm going to start by writing my x, but since my radical is in the denominator, I'm going to add a negative outside of that fraction. My root here, invisible, it's 2. We talked about that. So the 2 goes in the bottom. And then my numerator is going to be my root, I'm sorry, not my root, my exponent, which is 7. That goes right here. So my final answer is x to the power of negative 7 over 2. And you can either put that negative with the 7, or you can leave it out front kind of like that. And like I said, it doesn't matter if the exponent is inside the radical or if it's outside the radical. It all means the same thing. That you can put it in either place. So the exponent is going to go in the numerator regardless of whether it's in the radical or outside the radical, as we see in C here. All right, let's do B. I'm going to start by writing my x, and my radical is in the denominator, so I have a negative fraction coming up. My root is 3. That goes in the denominator. And my exponent is 2. That goes in my numerator. So my final answer is x to the power of negative 2/3. All right, final one. X to the power of a negative fraction, because it's in the denominator. My root is 3. That goes on the bottom. My exponent is 4. That goes to the top. So my final answer is x to the power of negative 4/3, or negative 4 over 3. Okay, and then final section, we're going to write stuff from exponential form to radical form. So rewrite the following expressions in radical form. So now this is very important to note. When we have stuff in exponential form, we see a fraction, right? We see something to the power of a fraction. That denominator becomes the root of my radical, and the numerator becomes the exponent in my radical, or outside the radical, and I'll show you both ways. Okay, so here we go. I'm going to start by writing the number 32. Now, I'm going to write also a root. I don't know what root it's going to be yet, but let's think about this. I know my denominator becomes my root, so I'm going to bring that 5 down, and it's actually the 5th root of 32. And then my numerator of my fraction, that 4, that becomes the exponent of 32. So this is the 5th root of 32 to the 4th power. And you can keep that 4 within the radical just like that. I'll also show you how to write it outside. It's just going to look like this. All to the power of 4. It does not matter which way you write it. Alright, let's do B. I'm going to start by writing my base, which is x. And I'll write a radical symbol. I'm not sure what the root's going to be yet. That's going to be a square root. Now you can write the number 2 if you want. You don't have to, because we know that if there's no root, or if there's no number, then we know it's a square root. And then my numerator, which is 3, becomes the exponent of my x. So now I have the square root of x cubed. And like I said, you can either write that in there, or you don't have to. You can put the 3 on the outside. Doesn't matter. C, I'm going to write my base, and I'll write a radical. So my denominator is 4. I'm going to bring that 4 down. That becomes my root. And then my numerator, which is 1, that becomes my exponent. Now you can write 1 if you want, but we all know that there's always going to be an invisible 1 outside of an x, because x to the first power is just x. So you can write this as the 4th root of x, or you can actually put the 4th root of x to the first power. Does not matter. They mean the same thing. Alright, and then we're going to do some with negative exponents. So we know that negative exponents just means we're going to move stuff to the denominator. So we're going to be moving the radicals to the denominator. So I'm going to start by writing A, B, and C as 1 over all of this. I'm going to change this to a fraction as 1 over 27 to the power of 2 divided by 3. Okay, that's what we're going to do for all of these. Now, I know I'm going to have to change this to a radical, but it's all going to stay in the denominator. So I'm going to have 1 over 27, and I'm going to create this radical to work with. Now, we all know that my denominator, you can pull it from either there or here, it's the same, is going to become my root. And then we also know that my numerator, which is 2, that's going to become the exponent of my 27. So my final answer for this should be 1 over the cube root of 27 squared. Okay, that negative means I just move everything to the bottom. Move to bottom, the entire thing. All right, for b, I'll start again by rewriting as 1 over x to the power of positive 2 over 7. Now when I move it to the bottom, I didn't mention this, your exponent becomes positive. It totally gets rid of the negative exponent. So it becomes to the positive 2/7. So now I'm going to create my radical. I'll start with writing my x. Now I have my radical, and let's see. My denominator, 7, becomes my root, and my numerator, which is 2, becomes the exponent of my x. So my final answer is 1 over the 7th root of x squared. All right, one more. I'm going to change this to 1 over x to the positive 1/2 power. And then I'll rewrite this with my radical. So I have x, and then I have some radical. Not sure what the root or the exponent's going to be yet, but this 2 in the denominator tells me I'm going to have a square root. Now, like I said, you can write that if you want. You don't have to, because we all know that if there's no number there, it's always a 2, always a square root. And then my 1, that becomes my exponent of my x. And you can write that if you want. You don't have to do that either. So this actually just becomes 1 over the square root of x. Or you could write in all the numbers and say this is the square root of x to the 1st power. So you can do this or that. It doesn't matter. It's all the same thing. Whatever makes you happy. Okay, so that's target 7. We did a lot in target 7, writing back and forth. Don't forget that the denominator in the fraction is always the root, and the numerator in the fraction is always the exponent under the root or outside of the root. And that's it. If you have any questions, don't hesitate to ask your Algebra 2 teacher.